All right. Well, I hope you are all doing well, and I can see that that 45 people have forked my repository, but I think that leaves still about 25 or about a third of the class that has not forked the repository yet. And so, you know, I do really want you to do that because I'm going to be posting all of my lecture notes on GitHub. So I'm not going to be, you know, you'll still be using CCLE to, you know, week one, I have a whole bunch of notes and stuff here, but pretty much starting in week two, it's just going to be like the CCLE, you'll use the lecture view quiz, but all of the notes and whatnot is going to get posted through GitHub, okay? And so I have already pushed and updated some stuff onto GitHub. And so just to kind of show you what you need to do to pull or fetch the changes that I've put in my GitHub repository, which if you've configured it correctly, it will be your upstream repository, okay? So this is, again, simulating your machine as a student. And so I'm going to switch into my directory, 2021 SP stats 21. That's where I'm going to have all of my lecture notes. And so you can see if I do that, I only have basically these three files. I have the README, lecture 1.1, and lecture 1.2. Now I actually renamed my lectures to start off with 1-1, 1-2, rather than at the end of the file. And so what I want to do is I want to fetch what I've posted into the professor's repository, okay? And so, you know, you don't have to do this, but if you have it configured correctly, when you type in git remote -v for verbose, showing the verbose configuration, you should see the origin and the upstream. Okay, origin will have your username in it, and your upstream will have Smiles Chen. Okay, Smiles Chen being the kind of the professor's account. All right, so if you have the upstream repository configured, then you should be able to do the next step, which will be git pull upstream main. Okay, and this tells Git to look at the upstream repository, and so it's going to go to the Smiles Chen website, or Smiles Chen on GitHub, okay? And it's going to fetch the main branch of the upstream repository. So I'm going to go ahead and do that, and it'll take a few minutes, and it says, oh, okay, all right, we've downloaded, and it downloads a whole bunch of stuff here, okay? So it says, look, we've renamed lecture 1-1 to 1-1, 1-2, and then it also has downloaded 1-3. And the 1-3, you'll notice there's the lecture, there's three files. There's the IPython notebook, the PDF, and then slides as an HTML. There's also two associated scripts that were uploaded as well. And so it's going to pull all of those things down. And so now if you've done that, and you list it off, all of your content is there, and you should be able to open and view today's lecture content. Okay. All right. Any questions there? Did anyone try that out just now? And did it work? Anybody encountering issues? If it worked, give me a thumbs up if you actually did that and it worked. Okay. All right. Okay. Well, great. So for some of you, it worked. So that's great. Okay. So I'm going to go ahead and going to go switch back to my own account, the teacher account here. But you should also be able to do this. Let me switch here. So hopefully, so I sent out a message. I said, please have Anaconda installed. And so if you have Anaconda installed, you'll be able to launch Jupyter Lab. Okay. Oh yeah, oh. Okay, so sorry, let me go back. So when you, a question popped up and it says, you know, the changes don't show up in the, so you do this and they show up on your local machine, but then if you go onto your GitHub, they aren't going to be reflected there yet, okay? And the reason for that is you have to push them. So, so kind of what we have, the status that we're in is you've done Git Pull, and that pulls it from the professor's repository to your local machine. And if you want to push from your local to your GitHub, then you'll have to do a Git push. So from here, you do Git push, and it's going to upload everything from your local machine onto your GitHub repository on GitHub. Okay, so it's a bit of a two-step thing here. So now that I've done Git push, hopefully this this should reflect the changes here. So I've done Git push, and that should do that. Okay, we have a question. It says, do we have to pull and push every time there's a change in the class repository? You don't have to do the push, but you will have to pull. Okay, so you'll have to do Git pull upstream master, or not master, upstream main. You'll do Git pull upstream main, and that's going to pull all of the changes. Okay, and I know in the beginning it feels a little bit clunky, and you're just like, why don't you just post things on CCLE? Everything's, but I think with a little bit of time, once you get kind of comfortable with the terminal, you'll appreciate this type of thing, and you'll just be like, oh yeah, I'm just going to do Git pull upstream main, and then all of the new files just show up, and they're going to be kind of organized the exact same way. All right. Now, one thing I do recommend is, if some of you, want to annotate things, you want to annotate the PDFs, you want to add your own notes and things like that, that's fine. What I encourage you to do is, I would say, don't alter these files directly. Make a copy, okay? Make a copy of it, so you would do something like, copy, if you wanted to copy the notebook, you do copy 1-3 lecture IPyNB, and then what we would do is we would to maybe I'll just call it my 1-3.IPyNB. Okay, and then so now we have a my version of 1-3, and then edit your version. Okay, and that way, if I, the professor, make any kind of changes to this notebook, and I push that change onto push that commit to GitHub, the next time it downloads, it will update this file, and there won't be any kind of conflict, right? Because if you edit the file and I edit the file at the same time, there can be a conflict. Sometimes the conflicts can be resolved easily. Sometimes the conflicts end up getting messy. And so to kind of just avoid that messy state, I would suggest that you make a duplicate, call it your version or something, and then make changes to that one without making any changes to the original file. Okay. So let's see. The question, is it already in the staging area? Is that why we can push without Git? Yeah, so when you do, so again, so after you do the pull, okay, this Git pull, it fetches the changes, and it basically commits them to your repository. The pull is will fetch, and it commits all of the changes. It basically pulls all of the commits I've made, and it adds them to your thing. So all of those commits get committed to your repository. So there's nothing in the staging area. Everything is already committed, and you're just pushing those commits to your repository. So you don't have to do a git add or git commit anything here. You just pull, and then you just push. All right. I hope that's okay. If you have more questions on Git and whatnot, maybe I'll be able to answer and stuff. Okay, so if you have Anaconda installed from your directory, you should be able to launch Jupyter. It's spelled Jupyter Lab. Okay, Jupyter Lab, and I'll hit enter, and that should open up a web browser. Okay, and so you'll see kind of some information here. If it doesn't open a web browser, then you'll see this line here. It says, to access the server, open this file in the browser or copy and paste one of these URLs. So if it doesn't open the browser, you can just kind of copy that and then open up a browser, and then hit enter here, and it will also open up the browser. Okay. And so this is what it will look like when you open Jupyter Lab, right? Is this working for you guys? Jupyter Lab. Okay. All right, great. Okay, and so Jupyter Lab. So Jupyter Lab is a newer thing. It's kind of a IDE, interactive development environment, that was created based around Jupyter Notebooks. Everything happens in your web browser, all of the interaction happens in your web browser. It's running this kind of local host server, and it's basically running Python. On the left-hand side, you'll see a file browser, and you should be able to open the IPython notebook here, okay? And so here is this one, 1-3, or for lecture stats 21, and this is a notebook, and you can do a few things, and this will have, so this is basically a Jupyter, what we call a Jupyter notebook, okay? And if you used RStudio, it's similar to an R Markdown file in that it combines kind of just regular text along with code chunks, okay? Except everything here is called a cell, all right? So you have what we call Markdown cells, and we have code cells, and it combines everything in this thing, and it's very popular for data science. Okay, let me go ahead, and I'm going to go ahead and open the PDF. Actually, we'll open up the lecture slides. So this notebook can get rendered as a slide presentation. Okay, and so you can see, this is what I have: introduction to Jupyter, IPython, and whatnot. And it gets and I've rendered it as a slide presentation, right? And so this thing says, there's a whole bunch of ways to run Python, and if you went to the Python website and you just downloaded Python, then the way you've been interacting with Python is just probably through the interpreter. Okay. There's other things, you can get IDEs like PyCharm and stuff. Jupyter Lab, I'd say, is one of the most popular choices for data science. And you launch it by Jupyter Lab. Jupyter Lab is centered around Jupyter Notebooks. And if you want to run the notebook by itself, you can also run Jupyter Notebook. But based on kind of the development by the Jupyter project, I think they're going to eventually sunset Jupyter Notebook and focus on Jupyter Lab. So I'm trying to transition things. I'm sorry, I don't know why my dog is barking or upset over there. Okay. So when you're in the notebook, there's two modes here. Okay. There's edit mode, which you can double click a cell and you'll enter it in edit mode. Okay. And if you hit escape, you'll be in what we call command mode. All right. When you're in edit mode, okay, your up and down arrows will work like up and down arrows. If you hit escape, your up and down arrows will switch from one cell to another cell. Okay. When here, if I just hit escape, you just see kind of the text as I've written it. Okay. What you want to do is you want to hit Shift Enter, and it's going to convert the Markdown into kind of rendered text. All right. Now, that was not an interesting thing to see, but here in edit mode, you can see, the way we just write headlines in Markdown is by using kind of the hash sign. Okay, and one hash is for a top level heading, 2 hashes for a second level heading, 3 hashes is for a third level heading, and then we can indicate code by using backticks. We indicate bullet points by using dashes. Okay, and so this is what the text looks like in Markdown, and then you hit Shift Enter, and it renders it into kind of it renders the formatting that you have applied. Okay. And so you can navigate through the Jupyter Notebook by using your up and down arrow keys in command mode, and you can see this bar shifting from one cell to another. Okay, and if you want to add a cell, you can use the toolbar here, right? So you can click the little plus button and it's going to insert a cell. And you can enter code like 3 + 6 and hit enter, and it will say, oh, that's the number 9. Okay. You can enter it and you can switch it from code to Markdown, and you can do 3 + 6. And if you hit Shift Enter, then it just renders it as text. So there are code cells and there are Markdown cells. And if you want to convert this Markdown cell to a code cell, you can go from the menu and you can switch to code. All right. And if I hit Shift Enter now, it will see it as code and it will do the calculation, and it will say 3 + 6 and it returns the result 9. Okay. Now, I strongly encourage you, rather than using the toolbar here, this toolbar is perfectly good, but I would strongly encourage you to try using the keyboard shortcuts and learn these keyboard shortcuts. Okay. A puts a code cell, inserts a cell above where you're located. B inserts a cell below. Okay. So, and DD deletes the cell. All right. So here I have this entire cell selected. I'm going to hit B and it's going to put a cell below. If I have this cell selected and I hit A, it inserts a cell above. Okay. If I want to delete this cell, I hit DD. If I want to delete this cell, I hit DD. All right. You can copy, cut, and paste cells by using X, C, and V. You don't have to hold down Control or anything like that. Okay. To switch between code and Markdown, you're going to use M for Markdown and Y for code. All right. So here I'm going to insert. So I have this right here. And you can go up and down. So you can use the arrow keys to go up and down, but you actually don't even have to remove your hands from the home row on your keyboard. You can use J and K to go up and down. J will go down, K goes up. All right. So you don't even have to move your hand from the home row down to the arrow keys. You can just use J and K to go up and down your cells, right? And so here I'm going to insert a cell right below here, and it defaults to being a code cell. But if I want to switch to Markdown, I hit M on the keyboard and it switches to Markdown. And you'll notice right up here, it says Markdown. If I want to switch back to code, I hit Y and it switches to code, right? And these are very useful keyboard shortcuts. I strongly encourage you to force yourself to try to do as much as you can on the keyboard and like hide the mouse. Okay. You can do a whole lot on Jupyter without lifting your hands from the keyboard and touching the mouse. All right. And if you force yourself not to use the mouse, you will use these keyboard shortcuts and you will get proficient and good with them. Okay. So let me, so I think this is what I've said. Keyboard shortcuts, A for above, B for below. Let me see if I can make this. Let's see, increase. How do I increase font size? I'll just zoom in here. Okay, that's fine. Okay. So add and delete. Okay, cut, copy, paste. Navigating, use J and K or use the up and down arrows. And then to switch between Markdown and code, M and Y. All right, this is just some basics of Markdown. So let me go ahead and just delete that. So for just Markdown basics, 1 hash will be a heading level 1, 2 hashes will be heading level 2, so on and so forth, down to level 6 hash. And if you try to do a 7th level heading, it just becomes normal text. Okay. If you're not familiar with Markdown, you should go to this website. Okay. And this gives you a very brief lesson, but it's a very good tutorial and introduction to Markdown. And Markdown is what is, when you have your, in your repositories, okay, this README file is a Markdown file, okay? Your README is a Markdown file. And so, learn the basics of Markdown. So this will be headings, bullets, you just do dashes, Italicize and bold is done with asterisks, right? You can also do math symbols using dollar signs. Okay, you put $2 around things, or single dollar signs for inline math, and $2 will make equations, right? And if you're familiar with LaTeX and typesetting, you know, E equals MC squared will get rendered like that. And you can do, much more complicated equations by using fractions and left side parentheses and things like that. And you can render, your LaTeX equations with using dollar signs. Right. So far, so good as far as using Markdown. Okay, and so if you have code, or if you want to render your Markdown into kind of formatted text, you're going to hit Shift Enter. All right, Shift Enter is going to render that cell and move to the next cell. If you're at the very bottom of the notepad and there's no cells afterwards and you hit Shift Enter, it's going to add a new cell. Okay. Other options are Control Enter. Control Enter will render the cell but will not advance to the next cell. Okay. So by default, if you hit Shift Enter, it renders it and it moves to the next cell. Okay. Here I'm going to hold down Control on the keyboard, and I've hit Control Enter. You'll notice this thing will stay in the same position. Okay. So Control Enter, I stay on the current cell. Whereas if I have Shift Enter, it moves to the next cell. It moves to the next cell. Okay. And then another thing you can do is Alt Enter. Alt Enter or Option Enter is going to insert a cell after the current one. So if I hit Alt Enter, it runs it or renders it, and then it inserts a new cell right here. Okay. And so those are kind of your options there. Shift Enter, Control Enter, and Alt Enter. Shift Enter is probably the most commonly used one, right? You're just going to hit Shift Enter to render your cells, right? And then regular Enter just inserts line breaks in your cell. Okay. The Jupyter runs on IPython. IPython stands for Interactive Python. Okay. And there's some nice features about interactive Python over just your regular old Python interpreter. Okay. And basically every single kind of thing that you run, you get this, you get a number that indicates kind of the cell operation and the corresponding output, right? So basic operation, I did 2 + 3, and it outputs 5. And I think if I hit Enter now, this is now the kind of the third operation I've run here, right? And so, and here I do, if you have multiple operations in a cell, only the last expression is going to get printed. So I've done 4 + 5 and 5 × 5, but only the last one will get rendered, okay? Or will get output, okay? If you want other stuff to appear, you can run something like print. You can do print 4 + 5, print 5 × 5, okay? But a thing about print is that print doesn't return anything. It technically returns an invisible null, okay? And so there's no, you'll notice that there's no output, right? So here, kind of it says I've got the input 3 is 2 + 3, and the output for 3 is 5, okay? The input for cell 4 is 4 + 5, 5 × 5, and the output is 25. And here the input is this, and you'll notice there's no 5 output. There's no output for 5. It's just, it's printing stuff to the screen, but it doesn't, this command or this function doesn't actually return a value, if that makes sense, right? So I can't do stuff with it. It outputs stuff to the screen, but I'm not, I can't run with it, okay? This has gotten a little bit messed up. Let me go ahead and restart my kernel and run all of the cells, just because as I was showing you and demonstrating things, these things went out of order, okay? So anyway, as you're running your IPython notebook, anytime you do something, so here, this has already been run. So if I do the whole cell, notebook has run, and there are 28 operations. And so if I rerun this cell up here, this is now says this is the 29th thing. Okay, and if I run it again, it's going to say this is the 30th thing, and this will become the 31st thing. And if I run this one again and I hit Shift Enter, it's going to say that's the 32nd thing. Okay, and so just to kind of keep things aligned, I'm going to go ahead and restart my kernel and then just run everything again. So it's kind of like restarting your session and running everything. Just because I do reference some of these other things. Okay, so a very nice feature of IPython is that all of the cells are preceded by kind of this kind of an input 1 and an output thing, right? So I've got cell number 4, and what you can do is you can actually say, well, what did you actually? You can reference each of these cells. So if I say what went into input 1, I would do in square bracket 1, and it's going to say, you know what, this is what you typed in. Okay, what you typed in was pound basic operations new line 2 plus 3. Okay. A question says, when you export, will it have the correct order? Do you have to restart the kernel before exporting? Okay, when you export, it's going to export whatever it is that you see here. Okay, so right now I have everything in the correct order, and it will export exactly that, right? But if I did this, and if I run this again, okay, this is now cell 29, and then if I say export the notebook as something, okay, it's going to show with the 29. Okay, so whatever you see here, it's going to export it that way, right? So if you want it kind of in the correct order, then you should kind of restart and run everything in the correct order and things like that. Okay, and so you can reference kind of the older cells. So I can say, well, what was input 1, and input 1 is still this. Okay, you can't see it. It's no longer appearing in the notebook, but it's stored in kind of like the history of it, and you can reference kind of the history. You can also reference the outputs. Okay, and so the outputs, output 2 says 25. Okay, and so we can just ask, what is the what were all of the outputs that came out so far? Okay, and says, so for the output for the first cell, which used to be this, is 5. Output for the second cell is 25. Output for the third cell, you'll notice that there's no output for the third cell. Okay, and so inside, and I haven't talked about dictionaries yet, but you'll see there's no output associated with a 3. It goes 1, 2, there's nothing for 3, and then it goes back to 4, because this is now the 4th thing. The 4th thing that came out was this, and then the 5th thing is 25. Okay. Your first 3 have stars instead of 1 through 3. I'll have to kind of take a look. Okay, and then and whereas the listing of in is basically a list with all of the commands that you've entered so far. So these are just some of the basics of IPython. So I've kind of entered all of this. This gets rendered as a notebook here, or as slides. I forgot. I should give you your view quiz answers. The first view quiz answer for today is the letter B. The letter B as in bear. Okay, the letter B as in bear. With Python, there's a few things that Python does that might seem a little strange to people coming from R and things like that. And so one of them is that you can perform math operations, quote, math operations with strings. So here I have the string hello, and I'm going to do 3 times hello. Multiplication with a string will just result in kind of that string being repeated and a longer string at the end. So here I have hello, hello, hello. Okay, so it just says, kind of, it's one string, but just has hello repeated 3 times, right? And then if you do addition with strings, it just concatenates them, right? So here I have hi plus goodbye gives me hi goodbye, right? But this is useful in, like, if you wanted to kind of craft a message using different pieces, you can kind of you know, you can imagine trying to send out some kind of email, and you can do hi plus, you know, someone's name, you put in a variable for the name plus comma, enter, things like that. And you can kind of piece together longer strings using, you know, addition and multiplication and things of that nature. When you have, with Jupyter, you can also execute scripts, okay? So over here, I've written a very, like I've written a hello world script, okay? So in the Jupyter lab, you can open up text files, or you can even create new text files with the editor. I think, text editor theme, I think is the dark theme, or you can switch to light theme, whatever you want, okay? And okay, and so this is the script. The script just says print hello world, okay? And you can execute the script by using %run script01py, okay? So I can hit enter here, and it runs that, right? And if I can edit this, and I could say hello stats21 exclamation point, and I'm going to go ahead and save this script here, and just save that. And so now if I run the script over here, it runs this script, okay? So you can edit the script and see the results here, okay? There's actually some really nice features of Jupyter Lab, okay? If you right-click the text file, you can create a console, okay? All right, and it says, you know, what do you want? Python, right? And within here, you can, let's say you're working on some kind of text script, you can kind of have this interactive thing where you have the script, and, you know, let's say I wanted to assign some value x equal to 3, okay? And as you operate these things here, you can hit Shift Enter on your script here, and it's going to get run inside of here, and then you can kind of work with the stuff. So you can edit your script, and you can see it run down in here as well, okay? And you can kind of just highlight the whole thing and hit Shift Enter, and it will run within here. All right, so this is a nice feature, is that you can kind of just open up a console related to the script that you're working on. Okay, so anyway, I've modified this script. It says hello stats21, and then again, you can run scripts that have been kind of written by using %run and then the name of the script. Okay, and this assumes that the script is located in the same file as your notebook, and obviously, if it's located somewhere else, you have to enter the correct path. Okay, you can have your notebook and the script work together. All right, so here I have another script, and here this it's going to print out the message hello plus name, and it prints out it's Friday. Okay, so that's the entirety of the script here. Okay, now I can say, well, you know, my name is Miles here, and I want to run this. Okay, however, when I run this, I get an error. Okay, it says run this, and it says name has not been defined. Okay, and that's because this script, when it runs, it's just running in kind of its own little environment here, and it doesn't see the variables that exist inside the notebook. All right, and so it comes back, and it says the name has not been defined. Right, it says, you know, on this line. So one nice thing about Python error messages is they're actually generally very helpful if you read them. And so so it says name hasn't been defined. Okay, and that's because name has been defined inside the notebook, but the script doesn't have access to that. So if you want to give the script access, to the variables inside the notebook, you do %run -i. -i says, you know what, when this script runs, give it access to the same environment of all the variables that exist inside the notebook. Okay, and then so if I run this, now it runs and it says, hello, Miles, it's Friday, right? And then we can change this. And then we can just say, we can call it hello friend. And then we can say name. And then if I run this, now it outputs hello friend and things like that. Okay. It's running the script, inserting the name there. So these are kind of nice things. Sometimes you want to write a script in its own separate text file, not necessarily within the Jupyter Notebook, and you can do that, and you can have your scripts run in this setting. Okay, and it's done using the %run command. All right. You can also run some bash and shell and cmd commands. Okay, and this is going to differ depending on your system, right? So all you do is you put a exclamation point in front of the command, right? So on a Mac or Linux system, you can print out the contents of a file with cat, right? So over here, I can do, you know, cat. So this is a Linux machine. I can do cat script o2.py, and then this it prints out the contents of the thing, right? And so you can also run that inside your Jupyter Notebook by running this thing. Okay. Now this is this instance is running on a Windows machine, so cat is not a Windows command, so it doesn't work. Okay, but you can do type. Type is kind of the equivalent for Windows, and if I do exclamation point type, it will run. Okay, so it runs kind of these shell scripts or these shell commands. So, you know, from within your, I think I can do exclamation point ls, not ls. I think for here it will be dir directory for Windows. Windows will be dir, but you can do exclamation point ls on your machine if you have a Mac or something, and it will run. Okay. Okay. Let me go ahead and give you your next quiz answer. Next quiz answer is D. D as in dog. D as in dog. Through here. Okay, so showing all of that. I don't know. Is it better for me to is it easier to see if I just use kind of the slides or the notebook here? I'm not sure. Okay. Slides are easier. Okay. All right. I guess if I want to demonstrate interactivity, I'll demonstrate on the notebook here. Okay. So let's say you're doing some calculations, right? So, or you're doing some work and you get some outputs here. So if I do 3 times 9, the output is 27. You can access the last value that it outputs by using the underscore character, right? So I can do underscore -2, and this will be the equivalent of doing 27 minus 2. Okay, and so, you know, especially if you're doing some kind of calculation, you take the square root and it's this big, long, ugly number. You know, rather than having to retype the command or something like that, you can just use the underscore, right? But this underscore constantly updates. So if I do underscore again, now it's 25. Okay, so if I did underscore times 2, this would be 50 and things like that. And so underscore is always going to be the last value that gets output. Okay, and depending on what you're doing in your Jupyter lab, right? So if I so I don't remember what the last thing I did was, but remember the last operation, apparently operation 41, I don't even know where it is. okay, the last output was 5, okay? So maybe it doesn't even show up somewhere. So so this is always going to be constantly kind of changing as things get executed. Okay, so you do have to be mindful of that. You can always ask for help. Okay, you can ask for help on a function, and it will print there. All right, so you can say help on print or something like that. Switch to code there. You can also do question mark. Okay, and the question mark prints out the help as well. Okay, and you know, you don't have to keep this in your thing, but you can get your help and find out, you know, how does some kind of function work within there. All right, so I'll just do some very basics of Python syntax, okay? And then next week we'll get a lot more into, you know, Python coding and whatnot, okay? So I think you guys are accustomed to this. You want to write comments, you use a hash, and it's going to comment out the text, and that's and it's very important to document your code and whatnot. You know, with the notebook, you can have entire cells that that add commentary and whatnot. But especially in some kind of script, it's going to be important to indicate what your comments are. Okay. Python doesn't use any kind of you know, like a semicolon to indicate the end of a line. All right. Similar to R, just the end of a line terminates the statement. Okay. You can use a semicolon if you want to run two commands within one line. Okay. And if you want to run, if you want a single line that has a whole bunch of stuff going on in it and it needs to span multiple lines, you can use a backslash, or you can put the whole thing inside parentheses. You have a couple different options, right? And then other things, just naturally as you're defining them, they're going to have, you might be able to run multiple lines, right? So here I've got one line, x equals 5. The next line is print x, and it outputs that. Here I have a semicolon, and it's running two commands, y equals 6, semicolon, z equals 7. And so these two get operated separately, and then I can add the two values together and get 13 or something like that. Okay. You know, generally it's preferred to just do one line, one command per line, and using the semicolon is, I would say, considered to be bad style, but it's but it functions. Okay. All right. Yeah. So that's what I wrote. Semicolons generally bad style. Okay. Here, if I want to have the line continue on multiple things, I could do 1 + 2 + 3 / backslash +4 + 5, and that will output that. Or, you know, if you don't want to do that, you can do a parentheses, right? What would happen if I tried to do, you know, a equals 1 + 2 + 3 plus, and then I hit enter and I go on to the next line and do 4 + 5. Okay, that would result in a syntax error. All right, so if I do equals 1 + 2 + 3 plus, and then I do 4 + 5, okay, we're going to get a syntax error because it sees the 3 plus, and then it says, okay, well, this is the end of the statement, right? And when it sees the end of a line, it says, this is the end of the statement, and it says, well, you didn't give me something to do here, okay? So here it's going to complain. If I did this, if I add a parentheses here, then we're okay, all right? Because of the parentheses, it recognizes, okay, we haven't reached the end of the statement. Okay. Here I'm defining a list. A list, I open a square bracket, and then, you know, it's going to keep going until it reaches the closing square bracket. I'll explain lists next week, but you know, this is something that just kind of starts things off. An interesting thing about Python is that it does not use curly braces. Okay, so in a lot of other languages, you associate code chunks or chunks of code or blocks of code with curly braces, and you attach them to an if statement or a for loop or something like that. Okay, Python doesn't do that. It relies entirely on indentation. Okay, and so when you're typing things in Jupyter, okay, and IPython, it's actually smart enough so that if you create an if statement, right? If x equals 8 and you hit colon and you hit enter, it automatically indents the next line for you, okay? Because it's expecting that to operate, okay? So it actually will indent for you automatically, okay? And I haven't covered conditionals yet, but I'm sure you've seen it in other classes, so I'm not too worried, right? So we're going to just start off by defining the variable x, and we're going to set it equal to 8, or we're going to, it's technically, I should say, we take the value 8 and we bind it to the name x. And then I have a conditional statement. If x is greater than 5, it's going to run these two lines. These two lines are indented, so these two lines are associated with the if statement. Okay, so it's going to say print x is greater than 5, print x, and then here we have print hello. This line is not indented and is going to run regardless of the if statement. Okay, so it's going to say x is greater than 5, it prints out 8, the value of x, it prints out hello. Okay, here if I have the same thing, but I set x equal to 4, okay, x is equal to 4, this statement, this if statement is now false, right? If x is greater than 5, this is false. So it's not going to run any of the lines associated with the if, right? So this is not going to get run. This is not going to get run. And only the print hello gets run, right? Because the indentation defines the code block, right? The block of code that's associated with the x greater than 5. Yeah. Okay. Here, I've changed the indent, right? So this print is this statement. I'm going to remove the indent, okay? And so I've removed the indent, which means only this line is associated with the if statement, okay? So here I have x equal to 4, and I say if x is greater than 5, it's going to run this. X is not greater than 5, so this line is ignored, okay? But it will print x, which is 4, and it will print hello because these two lines are not indented, okay? And so Python uses indentation. So indentation is very important in Python. I think the indents can be as small as 2 spaces, okay? In general, your indents are going to be 4 spaces. You can actually configure that somewhere. Okay, text editor indentation. Oh, maybe they can be as small as 1. Okay, but yeah, generally 4 spaces is kind of I would say the most commonly used tab level. Okay, and if you hit tab, it actually inserts 4 spaces. Okay, so it doesn't actually insert a tab character; it inserts 4 spaces into the text there. All right, and so so you have that, and this will serve as just kind of our very first taste. If you have not already installed Anaconda, please make sure you do install Anaconda. Do play around with the Jupyter Notebook, okay? And see how much you can do without using your mouse, okay? Get into the idea of inserting new code chunks, navigating up and down, using your keyboard shortcuts, using Shift Enter or Control Enter to render and run your code cells. Okay. All right. We'll end here, and your last view quiz answer for today is the letter E. The letter E as an elephant. E as an elephant is your last view quiz answer. All right. We'll end here. And have a good weekend, you guys. I'm working on the instructions for homework 1, so you can probably expect that sometime next week. your first homework assignment, and I'll probably post a couple chapters in data camp for you guys to do, and I'll make sure I give you guys enough warning and lead time to get those chapters done as well. All right, we'll see you guys on Monday. Have a good night, or have a good weekend. So how do you properly shut down Jupyter Lab? You're gonna do file shutdown, okay? And that's going to shut down the server running Jupyter Lab here. Is there a limit to the number of inputs and outputs? I do not believe there is a limit to the number of inputs and outputs. I think that list and that dictionary just keeps growing and growing and growing. So, I mean, limited by your computer's memory, I guess.